Let's talk about how you can learn AWS for data engineering. When you decide to learn about any cloud platforms, you will understand that there are so many different services available in the market. The thing is, you don't need to learn all of them. As a data engineer, we just need to focus on some of the data services that we will be using for our project on day-to-day basis, and then we also need to learn about some of the fundamental services that are common across different cloud platforms. In this video, I want to talk about some of the AWS services that you will use as a data engineer. Not only this, I will also explain you how you can use these services to build the final project by understanding some of the case studies. So it is not just about understanding different services, it is also about how you can combine all of these services together to build your final data engineering project. So we'll go step by step. First, I will explain you all of the basic services, and then we will look into some of the case studies that is available on AWS platform. So without wasting time, let's get started. The first service on our list is Amazon S3. Simple storage service. In simple terms, this is where you will store all of your data. So as a data engineer, we extract data from the multiple sources. We transform that data and load that data onto some target location. So Amazon S3 is the center of your work because all of the data that you extract will be stored on Amazon S3. All of the raw data that you transform will get stored onto Amazon S3. So what is Amazon S3? Amazon S3 is an object storage. So you can store any types of file you want to store, structured, unstructured, such as images, videos, MP3 files, CSV files, and all of the other files. So when we store any file inside our local computer, it is considered as a file storage. Everything is stored in a hierarchy, but inside object storage, each and every data is considered as an object. So we have a bucket, and inside that bucket, each and every file that we store will be considered as an object. So basically, S3 is where we will store all of our files or data that you extract from APIs, RDBMS, or any application will get stored onto S3. Second service on the list is AWS Glue. Now we already talked about the extraction, transformation, and loading part. All of these things needs to be done, and we have to write some kind of scripts or use some kind of tool to perform all of these operations. This is where the AWS Glue comes into the picture. The extract part of the ETL pipeline, the transformation, and the loading part, you can write it on AWS Glue. So it supports Python, PySpark, or Spark language. So if you want to write your transformation script, you can write it on AWS Glue. The best part about AWS Glue that it is serverless, so you don't have to worry about scaling your job. AWS will take care of everything. You just need to focus on writing your script. On the other hand, we have a service on AWS available called as EMR. Elastic MapReduce. While AWS Glue is a serverless, for EMR you need to manage servers or cluster. The cluster is basically a collection of different servers. So it has leader node and the worker node. A leader node makes sure everything works properly, and worker node actually performs the task that you provide. So if you want to process large scale data, and if you want to write your job in Hadoop MapReduce and Spark, you can use EMR for that. The next service on the list is Redshift. Now everything we did, which is basically extracting data from multiple sources, transforming that data, and then loading that data. The loading part of the ETL pipeline, this is where the data warehouse comes into the picture. So basically we load our data and then we prepare it for the final analysis. So any data scientists, machine learning engineers, or generally a data analyst goes to data warehouse, tries to query that data using SQL, structured query language, to understand what is happening inside data, so that businesses can take decisions, build dashboard, and extract insights from it. So Amazon Redshift is basically the data warehouse service provided by AWS. The thing about Amazon Redshift is that we actually have to load our data inside the data warehouse so that we can start querying our data. But on the other hand, we also have the services available where you don't have to worry about loading your data, and you can directly start writing SQL queries on top of it. And the service that does this job is called as Amazon Athena. So when we write our transformation logic, we transform that data and we store the transformed data again onto Amazon S3 so that we can process it and we can start querying that data. So in the case of Amazon Athena, we can directly build a table on top of the files that we have stored, which is the transformed data, and directly start writing the SQL query. This might be a little bit trickier to understand if you are new to all of these different services. So in the case of data warehouse, we basically store our data onto data warehouse itself, but in this case our data stays on S3 itself. We do not touch our data, but we can use Amazon Athena to directly query on top of the files that we have stored inside the S3. So your data stays on S3 itself and you do not modify it, but you can start writing SQL queries inside Amazon Athena to extract insights from it and to understand what your data contains and get more understanding about the overall data that you have transformed. Another amazing service you will use as a data engineer, it is called as AWS Lambda. So many times when you are working as a data engineer, you might have to write some basic transformation script to transform some data, extract data from some API, or do basic operation or some automation. This is where you can use AWS Lambda. AWS Lambda is a serverless compute service provided by AWS where you just focus on writing your script and everything will be managed by AWS itself, and you can write your scripts in multiple languages such as Python, Node.js, Golang and many more. The best part about AWS Lambda is that you can set different types of events and triggers. So if you want to run your code at let's say 9 a.m, you can have a trigger for that. You can also set the trigger as that whenever the new data comes onto Amazon S3, your Lambda function should run. So you can use AWS Lambda for writing small script and automate your entire data pipeline. Now all of the things we talked about till now, we were just mainly focusing on the batch processing. It's basically we were getting some data into batches and then having our data processed at particular time interval. Now what if we want to process our data in real time? Because we also have data coming in real time from the sensors, stock market and all of the different sources, we have to make sure that all of this data gets processed in real time. And for that we have a service available on AWS which is called as Kinesis. In today's world we want everything in real time, so we have a lot of different applications such as Uber, Google Maps. All of these applications are running onto real time basis. So when you have data coming from the multiple sources and if you want to process them in real time basis, then you can use Amazon Kinesis for that. Another service you will use as a data engineer, that is called as DMS, data migration service. A lot of companies have their data stored inside their own data center. So what they do, they go buy RAM, hard disk, processing power, everything, and they build their own data server which is called as on-premise data center. So they want to migrate everything to the cloud platforms, and this is where the DMS comes into the picture. When you want to migrate your data from one source to the target source, data migration service will help you. When I got my first job as a data engineer, I was working on a lot of different migration projects. The migration projects are basically if you want to migrate from Oracle to Postgres, MySQL to Postgres, or let's say PostgreSQL to Amazon S3, PostgreSQL to Redshift. All of these different processes are considered as a migration. So you take data from one source and put that data onto some target location. It can be object storage, another relational database, or data warehouse. So this is where you will use DMS, data migration service. Now these were some of the main services you will need to focus on as a data engineer, but there are more services. AWS keeps innovating and bring more services in the market to solve particular problems. Some of the services are lake formation, specially designed to build a data lake on AWS. Manage workflow orchestration for Apache Airflow, basically the Airflow on cloud, so you don't have to worry about installation and management. AWS will take care of everything. You just focus on building your DAX and creating your data pipeline. QuickSight BI tool offered by AWS. RDS relational database service offers PostgreSQL, MySQL, MariaDB, Aurora and many more. So these are basically considered as a data service, which is basically we use it to process our data, store our data and do the data related work. But there are other services you need to know as a data engineer that are fundamental and common across all of the different cloud platforms. That includes VPC, virtual private cloud, generally used for networking and the security. Second is EC2, Elastic Compute Cloud. Consider this as your online computer. SNS, simple notification service for notification purposes. CloudWatch to understand log. IAM, Identity Access Management to manage your users and roles. So all of these are individual services that you can learn as a data engineer, but it is not only about learning these services. You also need to understand how you can combine these services and make them work together to build your final data engineering project. So let's understand some real world example and how companies across the world using these services to solve their day-to-day data problems. So you can find many different blogs like this on AWS platform. So I will put the link in the description. If you want to learn more about these different case studies, you can go and read them to understand more about this. So this is one of the case studies how JB Aviation built a cloud native data pipeline at enterprise scale using AWS platform. So basically they had their entire data infrastructure on on-premise server and they wanted to migrate to AWS cloud and see how they can replicate the similar architecture on cloud platform. So the main services that they used was Amazon S3 for their foundational data lake, and then they use Amazon Athena, Glue for ETL, and Amazon Redshift for their data warehouse. So this is what the initial data architecture diagram looked like on AWS. They had some data coming from the on-premise network and some transformation logic place. They used to load that data onto Amazon S3. So basically we loaded our data onto cloud platform. So once they have the data onto S3 bucket, then they use AWS Lambda to do the basic validation check and then use simple queue service, which is basically to pass different messages between different services available on AWS. So after the validation is done and if the data looks good, then they used to pass this data to AWS Glue to convert the CSV data to the Parquet format and write that data back to S3 again. So they just wanted to do the basic transformation, which is basically converting our data into CSV to Parquet format. Once they have the Parquet files available on S3 bucket, then they again use the AWS Lambda to validate that data with the CSV file. So this is how the companies generally start with the data architecture diagram. They start with a very small problem, they try and see how this works in smaller scale, and if it looks good, then they try to build other processes. So after the CHV to Parquet conversion is done, then they can add more processes, such as they can create database tables and load that data onto some kind of target location. So just like this, there are many different companies that uses AWS services to process their data. Let's look at one more example. Book My Show. So if you live in India, you might already know that Book My Show is generally used to book your tickets to movies, music concerts, and many more. So how Book My Show saved 80% in cost by migrating to an AWS modern data architecture. So just directly go to this, and what they use is AWS EMR, Glue, Athena, Lake Transformation, Apache Airflow, QuickSight, Redshift, SageMaker. So they use a lot of different services on their data architecture. So let's go below and see what the data architecture diagram actually looks like. So this is what the entire data architecture diagram looks like. So as you can see it over here, we have data coming from the multiple different sources. When I told you in the start of the video, we have data coming from the multiple sources. In this case, as you can see, it is coming from the mobile client, some common database, Kafka is set up, then they have like source database, data ops database. So they have data coming from the multiple sources, and then in the step 2 they have the Amazon EMR, Elastic MapReduce, to do some basic transformation, which is basically combining all of this data and putting that data onto one place. In this case, it is Amazon S3, the raw data. After that, they also have Amazon EMR again in place to do some transformation and curate this data and store that data again onto S3. So as you can see it over here, EMR, S3, EMR and S3. So you can have multiple EMRs, you can put Glue in between. According to the requirement, you can choose the services and do the job. So once they have the data stored on Amazon S3, the curated data, then they use AWS Glue to transform that data and build table onto Amazon Athena, as you can see it over here. So they build the Glue catalog so that you can query your data on top of files using Amazon Athena, but they also loaded that data onto Amazon Redshift so that if you want to do some analysis or create the visualization, you can do it using Amazon QuickSight. So this is one side of the picture, which is basically processing data for the data analytics, but they also wanted to provide this data to the data science team so that they can build machine learning models and find some insights. So once they have their raw data and the curated data, they also had the EMR, and the data science team wrote their own transformation logic according to the machine learning model. Again, store the process data and use Amazon SageMaker. If you want to train your machine learning model on the large scale, you can use Amazon SageMaker to do that. So this is how companies use these AWS services to build their entire data infrastructure and solve their data problems. I hope you found this video helpful, and if you did, then make sure you hit the like button and subscribe to my channel for more of this content. Thank you for watching. I'll see you in the next video.
Thank you.